You ever get the feeling there are hidden rules to the game of reality? That on the smallest possible scales, the universe has a secret rule book, and some moves are just completely forbidden. Well, you're not wrong. Today, we're cracking open that rule book and looking at the cosmic laws that act as the ultimate gatekeepers of the quantum world.
Right? Imagine playing a game where some moves are just off-limits. You can't do it. At the quantum level, the universe has its own set of illegal moves. An electron can't just jump to a new energy level whenever it wants. A photon can't always be absorbed. So the big question is, why? What's really stopping them?
Well, the answer isn't some kind of mysterious force field. It's actually way more elegant than that. See, the rules are built into the very identity of the particles themselves. So to understand the rulebook, we have to look at the players in the game and the unique little ID card that each one carries around.
So what's on this quantum ID card? It really all comes down to two fundamental properties that define a particle's identity in a given state: its spin and its symmetry. Let's break down what those actually mean, because they're not what you might think.
First up is quantum spin, and right away, let's be super clear. This isn't like a tiny spinning top in the way we think about it. It's a fundamental, built-in property, just like a particle's charge or its mass. It's a form of angular momentum that's quantized, which just means it can only have very specific, discrete values. The simplest way to picture it is like a little internal arrow that can only point either up or down. That's it.
Okay, the second part of this idea is symmetry, or what physicists sometimes call parity. Now this one gets a little more abstract, so stick with me here. It's a property of the particle's wave function. That's the math equation that describes its whole quantum state. Parity basically tells us what happens to that wave function if you were to flip its coordinates, kind of like looking at it in a mirror. Does it stay exactly the same, or does it get inverted? That's its parity.
So you take its spin up or down and its parity, same or inverted, and you have a unique, unforgeable ID card for that particle in that specific state. And this ID is what dictates exactly how it's allowed to interact with the rest of the universe. Which brings us to the gatekeeper that actually reads this ID.
This is where we finally meet the quantum gatekeeper. This isn't a particle or a force, but a set of principles known as selection rules. You can think of them as the bouncers at the door of every single quantum interaction. So what is a selection rule exactly? Just think of it as the universe's official codebook. It lays out the precise conditions under which a particle is allowed to change its state. For an electron to, say, absorb a photon and jump to a higher energy level, the change to its spin and its parity has to be on the approved list in that codebook.
Okay, so let's walk through exactly what this gatekeeper does. A particle is chilling in state A, and an opportunity comes along for it to transition to state B. The selection rule first checks the ID of state A, its spin and parity. Then it looks at the ID of the potential state B. It compares the two and checks its rulebook. Is the change from A to B an approved move? If the answer is yes, green light, the transition is allowed. If not, nope, red light, that transition is forbidden.
Now this is a really crucial point. Forbidden doesn't actually mean impossible. It just means incredibly, fantastically unlikely. An allowed transition happens almost instantly, boom. But a forbidden one, that could take nanoseconds, or it could take minutes, hours, maybe even longer. And believe it or not, you've seen this in action. That slow, lingering glow from glow-in-the-dark stars on your ceiling? That's the light from billions of electrons finally, slowly making a forbidden transition back to a lower energy state.
And this isn't just some quirky piece of quantum trivia, not at all. Understanding this rulebook, knowing which moves are allowed and which ones are forbidden, is the absolute foundation of some of our most important modern technologies. This is where the real genius of science and engineering comes in. When a physicist sees a rule that says no, they don't just stop. They ask, okay, but how can we use this? As the quote says, the forbidden transitions are not impossible, just incredibly improbable. But in that improbability, we find incredible utility. It's all about turning a cosmic "no, you can't" into a technological "oh, yes, we can."
I mean, just look at this. This quantum rulebook is the secret ingredient behind so much of our world. Lasers, they work by forcing countless atoms to make the exact same allowed transition all at once. MRI machines, that's all about manipulating the spin selection rules of atoms inside your body. Even the LEDs lighting up your screen right now and the solar panels on your roof are all engineered to maximize specific allowed transitions. We are quite literally building our world by harnessing these fundamental rules.
So the takeaway here is pretty clear, right? These selection rules, this cosmic gatekeeper checking the ID card of every single particle, it isn't some obscure principle just for physicists. It's the fundamental blueprint that engineers use to design the future.
You know, it really makes you wonder, doesn't it? These rules were completely hidden from us for most of human history, and now they literally power our civilization. What other cosmic rulebooks are still out there, just waiting for us to decipher them and unlock the next wave of incredible discovery?